Welcome to my YouTube channel. Today I will talking about branch current method. So you can see today here the board is a bit crowded, but bear me, if you follow very well, you understand what I'm going to be talking about. So when it comes to branch current method, it's a method that we are trying to use to find the current flowing through a circuit diagram by assigning current to branches in the circuit diagram. And as a result of this, we can write equations or drive equation from the circuit diagram by applying what? Kirchhoff's voltage law and Kirchhoff's current law. If you don't understand Kirchhoff's current law and Kirchhoff's voltage law, you can pause this video. I've made some videos on that, so you can go and watch those videos before you come here and then try to understand branch current method. Now, when it comes to branch current method, how do we use it or how do we apply it? We apply it based on steps. So we have applied by following some laid down steps. And I'll be talking about the steps. The first step is that you assign current to the branches in the circuit. Then the second step, step 2, you indicate the direction of the current on the circuit diagram, right? Then after that, you write the polarities on the resistors in the circuit diagram by looking at the direction of the current. So according to the direction of the current, then you write you indicate the polarities on the resistors in the circuit diagram. Now the third step is you apply Kirchhoff's voltage law to the loops in the circuit diagram. So if you can find loops in the circuit diagram, for each loop, you apply Kirchhoff's voltage law, and then you get an equation out of that, right? Then the fourth step is you also apply Kirchhoff's current law, this time Kirchhoff's current law to the nodes in the circuit diagram. So if you can identify a node in the circuit diagram, then you can apply Kirchhoff's current law to the node, and that will give you another equation as well. So we start with a very simple circuit diagram. You can see this one here. You can see for this one, if you look, we have R1 and R2, they are actually connected in series, right? Connected in series. So by looking at this simple circuit diagram, if you are to use branch current method, so you can see here, the first step, you assign current to the branch in the circuit diagram. You can see we have kind of two branches, but here is just a simple node, right? We have a simple node. A branch is the path between two nodes. So this is node, but it's a simple node. It's just a connection of two components. Another one is here. So you can see here, we have kind of one branch, or even two branches in that sense, but the same current is passing through the resistors, right? And into the voltage source. So as a result of this, we have only one current here. Then the second step, which is you indicate the polarities on the resistors based on the direction of the current. So you can see here the direction of the current here is coming this way. So the polarities on the R1 is going to plus minus. So the first terminal when the current enters the resistor is positive. When the current is negative. So the same thing you see here also the plus minus on the R2 resistor. Then we go to the third step, which is you now apply Kirchhoff's voltage law to the loops in the circuit diagram. As you can see here, we have only one loop, right? So we are going to go ahead and write the equation on this. Then not only that, you can also see clearly we have only one variable, which is we are trying to find the current in the circuit diagram, and we have only one current. So we need only one variable. Then only one equation is enough to get that current. So as you can see here, we can apply Kirchhoff's voltage law. Then what do we get? We get here to be V minus I times R1. Here we are moving clockwise. Okay. Once you are about to apply Kirchhoff voltage law, you will choose your direction, right? So you can move clockwise or anti-clockwise. So here I'm moving clockwise, and here with minus to plus, which is rise, and then here we have drop. That what minus will have current times what? R1, that will be the voltage across R1. And then here to plus minus is drops to we have minus here. And then the voltage across R2 is what? I times what R2, we get this equation. Then you solve for what? Your current, and then you get the current passing through the resistor for this simple circuit diagram. Now, what if we have a situation whereby we don't have such a simple circuit diagram, but we have to have something of this nature? Again, this is an example. So you can see now we have what kind of 3 branches, right? We have here 3 branches. And then as a result of this, we can assign the first step, who says that we have to assign current to the branches. So we assign 3 current to the branches, but we have 3 branches here. So here I have I1, I2, I3. And then when it comes to the direction, it's arbitrary. You will decide the direction that you want the current to be what? To be passing through. Whether it will go in this way or this way, you will decide the direction. So you see all my current I1 is going this direction. I1 and I2, they are leaving this node here. Now, the second step, you indicate the polarities according to the direction of the current. You can see clearly here, I2 is entering the resistor R1, so we have plus minus. The same, I2 is entering R2, so we have plus minus on this. Then we go to the last one, which is R3. R3 is going down on what? R3. So we have plus minus, and then I've indicated the polarities. Now we go to the third step, which is to write the equations by applying Kirchhoff voltage law to the loops that in the circuit diagram. So here I have 2 loops. Actually, we have 3, but 2 is okay, right? Because you can see we have 3 variables. While I need 3 equations to solve for the 3 variables. So if we have 2 loops, using these 2 loops, then after that, I'll apply Kirchhoff current law. That will give me the third degrees. So here, with the Kirchhoff law being applied to loop 1, what do we get? Again, we choose your direction. We have loop 1, we choose the direction. I always move clockwise. So here, when you move clockwise, then you see that here, minus to plus is rise, and then all the resistors here you get drop. So we have V minus I2. See, I2 is entering R1 minus I2 times R2 equals 0. So that will give us our first equation. You simplify this and label as equation 1. Then we come to this loop 2. Again, we are applying Kirchhoff voltage law to loop 2. Here you can start from any voltage. So here, as I decided to start from voltage V1, right? In the voltage across the R1 resistor. And you can see here, I'm moving clockwise. So here with minus to plus, that will be rise. And then when you come to here, plus minus is drop. So you can see how minus I3 times R3, that will be the voltage there. Then we come here, minus to plus is drop. So we have I2 times what? I2 times R2 equals to 0. That will give us our second equation. Then we can now go ahead by applying Kirchhoff current law to the nodes in the circuit. That is going to be our fourth step. And then when you do that, you see that you get this equation, I1 equals to I2 plus I3. And here you come here, this is our node A. So at this node A, I1 is entering and I2 and I3 are leaving. So we have this. So this will give us the equation. Now you can solve for this equation to get I1, I2, and I3. So see you in the next video. Bye bye.